So welcome, Carolyn.
Hi. All right, so let me just see if I can move this ahead. Okay. So this is a talking about roll-to-roll manufacturing, additive roll-to-roll manufacturing, and I want to talk primarily about why you would go roll-to-roll, some of the advantages of high resolution, and then where Kodak is putting their effort today. So my organization is in Rochester, New York. All of Kodak's advanced materials and chemical manufacturing is in Rochester, New York. We have clean room manufacturing facilities that I will get into in a little bit, and it's about 100,000 square feet for just the printed electronics organization. All right, so we partner with customers in printed electronics in three ways. The first way is enabling others to do high resolution flexography. So we have a suite of pre-press solutions. We will make plates for you, or we will sell you pre-press equipment for flexography. And when I say high resolution, so we're all on the same page, I mean 12,800 DPI at the design phase, so 2 micron pixels in design. And depending on how you're using that to print, you can achieve somewhere between 6 and 30 microns on substrate. It really depends on what inks you're using. So, like I said, we enable customers through providing pre-press services. We do what we call direct print, which most of the industry just calls printed electronics, right? So we print conductors, silver, we print dielectrics, and we have a 7-station press, really 8 stations, 7 Flexo stations, and an inkjet for genealogy. And so we can stop at the end of that press and have a fully functional product, and so we do that for some of our customers. For a lot of our customers, we use our full value chain, if you will, our full manufacturing flow, which in the print step prints a catalyst. And the benefit of that is it's a very thin layer, and so you don't have a lot of spread because you're not putting down a lot of material. And so that enables us to hold very fine lines. So we print a catalyst. Again, we have 7 stations. We can load catalyst on all those stations if we want to. We can print front and back. And then we have a fully patterned but totally not functional piece of plastic rolled up on itself, transfer it to the second clean room where we have an electroless plating line. Electroless so that our features can be disconnected electrically. It's slow, but it's powerful. And so we do pattern substrate in, fully metallized substrate out. Our metal of choice is copper, and it has an inorganic passivation on its front surface that provides stability as well as neutral color because we do a lot of optical applications. And so then we have a whole bunch of end-of-line testing to make sure that we have all of the customer properties matched or aims and tolerances are made. And we do our end-of-line RF tests for some of our antenna customers. All right, so here's just a quick overview of what I said in kind of what the product might look like. And so if you're going to go all the way to the print and plate, so on your right-hand side, those are optical micrographs, actually taken with an optical microscope. So we typically use a geometric mesh to get our optical transparency. Copper is obviously opaque. The transparency comes from the open spaces, so you see through the substrate. The patterning is analog, so we use Flexo. I'll talk about that in a minute. But the design is digital. So we choose a mesh. We can change the line width. We can change the pitch. We can make it rectilinear. We can make it circular. You can make it wavy. Whatever you need to get the optical effect that you're looking for in combination with the electrical effect that you need. So we do electroless deposition of copper. You can see we have fairly good grain structure, very low defects, and on that top surface, that inorganic passivation, which also operates as a darkening agent. And so, again, we did that by printing a catalyst. You can kind of see it. So the PET is black in a cross-sectional SEM. And then the kind of surface roughness that you see at the interface between the PET and the copper is the particles of our catalytic ink. So the fine lines of the micrographs were generated by the Flexo plate printing the catalyst. That's an SEM of the plate itself. That's the kind of macro scale of the plate wrapped around a cylinder. And Flexo, as we'll talk about in a second, transfers ink from the top surfaces, as opposed to gravure, which would transfer ink from the wells. Right. So Kodak is really focusing on Flexo for features. Like I said, we have 3 ways that we partner with our customers. We have hundreds of years of experience baked into our teams. We do very high resolution, 12,800 API. We work in the clean room, so we limit the number of particles that any product is, subjected to. And we do roll-to-roll processing, which is really the main theme of this talk, right? So we make thousands of square meters of product. our web